Hello everyone, welcome to Geoscience Point channel. Today our topic is linear scale. Today is a video scale video number part 2. In part 1 we discussed about the basic concept of scale, and from today this is a part 2 video where we will discuss the linear scale and its drawing way, how to draw it and what is the linear scale. We will discuss about it, and serially the video will be published on different types of scale and its drawing. So today's topic is linear scale. So before telling about it, we will show what is linear scale and where we can see it. Basically, we told about in our part 1 video that scale is used on a map. Linear scale and RF scale, different types of scale used is on map. So how is it used on a map? I will show you an example. This is a map of India. This is a map of India, and where this map has been drawn on a particular scale. Which scale? On which scale? This scale. This is the scale that is a linear scale. This is the scale where here it is drawn on a line types. It's a drawing pattern. And what is the map scale? This is the map scale and it has been drawn like this. So we will discuss on this type of linear scale today. So what is linear scale? Linear scale is a drawing pattern of a statement scale and RF scale. We already discussed in last video. That means linear scale is always draw based scale, which is drawn on a line, That's why that is linear or linear. From line it comes linear scale. Now whenever you will solve your exercise, you will start doing exercise on scale. The first topic you have to do this linear scale, and you have to solve the equation or question in your exam or at home as an exercise on linear scale. So what you have to do on linear scale? There will be a problem. A problem will be given to you. Suppose what is the problem? Suppose the problem is draw a linear scale. That means you have to draw it. What you have to learn from this scale part, from this video, you have to learn the mathematical calculation of linear scale and drawing of linear scale. Draw a linear scale to show 15 km on primary division and 3 km on secondary division, where the RF is 1:5 lakhs. This is a problem. Now just understand the problem first. There will be a mathematics, there will be a question like this, where two words you will get, one primary division and secondary division. Suppose there is a scale. If it is a linear scale and it has total two parts, that is primary, here will be 0 and this side will be primary and this side will be secondary. So if a primary division, that means this particular distance, suppose this distance may be 1 semi or 1 inch. This distance represents 4 km or 4 miles. So this particular distance 1 semi represents 4 km or 1 inch represents 4 miles. That is primary division. And to understand the more smaller division of it, that is secondary division, and the half of the primary division. Suppose this primary division has been divided into two parts, one part and two part. This two part means this part represents, this small particular distance represents 2 km and this particular distance represents 2 km. So from this part, the particular distance we can understand, and we can understand what this particular distance of map is representing, what kilometers or what miles of map distance, ground distance. So that is linear scale. We can understand the map ratio between the map and ground through drawing. That is linear scale. So what you have to do? First of all, you have to do, just you will mind that in the first step calculation, you will start calculation. First step 1, that is step 1, Step 1, what will you do? You will do that 1:5 lakhs. You will focus on it. It means 1:2 means 1 semi on map represents 5 lakhs means ground. So 1 semi on MD, that means map distance, represents 5 lakhs semi on ground distance. And you have to determine from this ground distance in semi to kilometer. Why? Because your primary division is given on kilometer. On which unit your primary division will be given here, you will extract the particular unit from this RF. So 1 semi on map distance equals to 5 lakh semi on ground distance. It means 1 semi on map distance equals to 5 lakh semi means how many kilometer? From centimeter to kilometer, you have to divide that particular number by 1 lakh. So I have divided it by 1 lakh and I have got 5 kilometer. That means 1 semi map distance represents 5 kilometer ground distance. So from RF through statement scale, we have got these two divisions. Now step 2. Second step, you have to do second step with primary division, that is P based step. 1 semi map distance represents 5 km ground distance. So we can write vice versa. 5 km ground distance represents 1 semi map distance. So we have to determine that 15 km ground distance, how many map distance will it be shown? If 5 km ground distance from the RF, we have understand that here in this map, it has been narrated that 5 km ground distance represents 1 semi map distance. So 15 km ground distance, the primary division, it is 15 km primary division. So we have to focus on it. In second step, 15 km ground distance will represent how many map distance? You will calculate it. 15 km divided by 5 km into 1 semi. So after this calculation, we are extracting that 3 semi map distance. That means 5 km ground distance it represents 1 semi map distance, then 15 km ground distance represents 3 semi map distance. That is our primary division, 3 semi. Step 3. Here we will discuss the secondary division. 5 km ground distance, same as it is based on the RF, we will calculate throughout this mathematics based on this RF. 5 km ground distance represents 1 semi map distance. So 3 km, that is 3 km on secondary division. In second step we have focused on primary division, and in third step we are focusing on secondary division. So 5 km ground distance equal to 1 semi map distance. So 3 km ground distance, how many map distance you have to calculate? Similarly like this, 3 divided by 5 into 1 semi, that means 0.6 centimeter. That is secondary division. Now step 4, number of secondary division. If 6 semi is 6.6 semi is the value of 1 secondary division and 3 semi is the value of 1 primary division, then how many secondary division may be drawn on a primary division? Simple, value of the number of secondary division equal to, this is the formula, mind it, value upon primary division divided by value upon secondary division. Value upon primary is 3 semi, we have written. Value upon secondary is 0.6 semi, we have written. That means 5 semi and semi cut. So 3 by 0.6 equal to 5. That means 5 number of secondary division will be there on 1 primary division. That is step 4. And now come to the last step, step 5, that is total length of the scale. When we draw the scale, we have to determine the total length of a scale. Generally, you will mind it, generally the total length is 12 semi to 18 semi in CGS method, in centimeter method, and if in inch method you will draw, then 5 inch to 8 inch. This is the basic criteria of a scale. Generally there is no particular criteria that the scale must be in between these two lengths, not that, but if we draw the scale in between these two lengths, then the scale looks like better. So if 4 number of primary division is taken, if we take 4 number of primary division on a total length of the scale, then what will be total length? 4 into 3 semi, because one primary division is 3. That's why total length will be 12 semi. Total length will be 12 semi. The total length may be, there may be a problem that draw a linear scale of 18 kilometer. There may be a new equation of 18 kilometers. Suppose it has been given here. Then what you have to change? You have to just change the number of primary division. 3 semi per division. And now if you take the 6 primary division, then total length may be 6 into 3 equals to 18 semi. This 18 semi or kimi, whatever, in scale that is semi, map distance, and in ground proper distance, that is kimi, whatever it may be, same. So these are the basic 5 steps you have to do for the calculation of linear scale. Now we will go to the next part, that is drawing, how to draw the linear scale. For drawing linear scale, you have to remember only what things? The total length of the scale, this one, number of primary division you have taken, number of secondary division you have taken. These 3 things you have to remind in your mind, these 3 things for drawing the scale. Okay? So now we will learn how to draw the scale. From calculation part, I told you that remind the main 3 things, that is the total length of a scale, number of primary division, whatever you have taken, and number of secondary division, these 3 things. So first you have to draw through a scale the 12th semi line. Suppose this line is 12 semi, and then you will draw in 45-degree angle a line of any length. This length is not measured. You can draw a line of in 45-degree angle in whatever measures. There is no particular measurement. Or someone draws the line perpendicularly here or perpendicularly in this 2 part. There are 2 processes. Either you may draw 45-degree line any distance, or you may draw any distance, the 2 lines, whatever you can. But here we will learn drawing 45-degree angle. This is 12 semi line, and this line is not measured. There are 4 number of primary division. How many number of primary division? Suppose there are 4 number of primary division, or there are 3 number of primary division. Suppose there are, in this map we have learned that 3 or 4, whatever, suppose 4, whatever it may be, 4 number of primary division. So you will cut the same distance 4 number. Suppose starting from here, dividing 1 semi or 2 semi or 0.5 semi, whatever you can, you will divide this line into 4 parts, because 4 number of primary division, 4 parts. If the number was 5, then you will cut this line in 5 parts. But the distance between these points, among these points, should be same. Whatever you can take, but the distance or length among this point should be same. The last one should be joined with the last part with the help of a scale. The last one should be joined with the help of a scale. Then you may take set square, or you may take help of scale. Set square means in your geometry box there is a scale, there is two parts like this. This is known as, this two part is set square. You will get a large set square also, this type of set square, large type. This is small type and this is large type. So you can take help from set square. Today we will learn with one set square and one scale. So after drawing this, you will take the angle of it, or you may take angle of it through a scale, and then put it in on the head of a scale. You will take here and join it. Similarly, but this should be fixed. One should be fixed and one should move. If you fix like this, then that will move, and if you move like this, then if you move this, that this will fixed. One will be fixed and one will move. Why do we do it? We do it for maintaining the inclination. In which inclination point this line has been drawn, the same inclination point should be in all point. And we will draw this. Then similarly we shall draw it, and last one we shall draw it. Then we will find that all these small points have been divided in an equal part. 12 semi have been divided in equal 4 parts, that is 3 semi. 3 semi. Thus, this is known as geometric division of a scale. This is known as geometric division of a scale. But in this scale, as our primary division was measured as 3 semi, one value of primary division was 3 semi and secondary division was 0.6 semi. So in this case, there was no need to draw a scale with this set square and geometric division. Why? Because we can get directly the distance of 3 semi from a scale and 0.6 semi from a general scale, from a general ruler, and we could draw it by maintaining it 3 semi, 6 semi, 9 semi, like this, 12 semi, and here also 12 semi, and then we could join like this. But why have I shown it to you? Because when the distance will be 3.36 semi and the secondary distance semi will be 6.66 semi, then we cannot get this fraction of length in this simple ruler. At that time, from the total division, if we make a geometric division, then we can get the fraction of semi in a large scale. That's why this geometric division is needed only when the value of one scale division is 0.6 semi or 0.66 and 2 decimal after point, and only for particular that time. So similarly, that we will draw one extra division here. Why one extra division? Because that particular part is for secondary division. One extra division. Maintaining this part, we will draw one extra division here also, and we will join it. What for? Because the left portion will be provided for drawing primary division. Secondary division. This is 0, this is, so 15 kilometer primary division. 15, 30, 45, 60 kilometer. Now we have to draw secondary division. Now how can we draw? We will make a straight line here. Any distance, any length straight line. There is no particular measurement of this line. And now how many secondary division we draw? 5. We have to remind it, the 5 number of secondary division. Then we will cut this line into equal 5 parts. Into equal 5 parts. 1, 2, 3, 4, 5. Similarly, we shall join the most top portion to the last portion, and maintaining this inclination, we shall join the rest portion with our rest part. Okay, with our rest part, we will join with the help of set square. With the help of rest part, all the distance will be same. 1, 2, 3, 4, 5. Total 5 division will be there, and each of division will be 3 kimi. 3, 6, 9, 12, 15 kilometer. This represents the smallest part of a scale, of a linear scale, through which we can measure comparatively smaller portion of a map, and this larger portion is the primary division through which we can measure the larger portion of a map. And lastly, you will point it like this, that is primary division, and secondary division, and in the below part you will write the RF equal to 1:5 lakh, and at the top you will write linear scale, the heading one, linear scale, this type heading. So thus you can draw a linear scale. I am repeating the process shortly. First you will draw the 12 semi line, then you will draw 45-degree angle and equal part of 4 parts, and then you will join the last one, and maintaining inclination you will join the rest points with the basic line, and then you will take one more part and you will join one more line for maintaining the secondary division, and then you will draw a line from the first point, and you will make 5 equal points from this in this line, and then you will join the last point in the last point with this baseline, and maintaining the inclination you will join the rest part. Thus you can draw a linear scale. That's it. More problem and equation will be given in our description link in this video, and if any problem you can query me through mail or commenting on our YouTube videos. Thank you. Dear students, you will practice the linear scale with different problems given in description link, and in our next class, in the part 3 of scale video, we will discuss about the comparative linear scale and its drawing procedure. So keep and stay with us, Geoscience Point channel, that will make your future better. Thank you.